Alright, and welcome to Quadrilaterals Level 4. Now, in our very first example, it says given quadrilateral ABCD is a square and line segment BD equals 18 inches, we want to find the perimeter. So let's kind of review some of our properties of a square. Whenever we have a diagonal, we know that it actually bisects this angle. It's one of the properties. And if it bisects that, we know also that the angles of a square are 90 degrees. So what does the word bisect mean? It means to cut in half. So this essentially gives us two right triangles when we look at that diagonal, where this diagonal becomes the hypotenuse. And also, remember that 90-degree angle was bisected, and ask yourself, what is half of 90 degrees? Well, that will in fact be 45 degrees. Now, not only is that 45, but if we have 45 and we have 90, then this angle as well is going to be 45. Now, why is that helpful to us? Well, we have a special right triangle. This is something that we talked about in the very first semester. It is called a 45, 45, 90 triangle. And here, I'll just use the right angle box there. Now, whenever we have a 45, 45, 90, we know that this hypotenuse, or the long side, is x square root of 2, and either side can be represented by x. Now, a lot of students are confused when you see this special right triangle for the first time. All it's literally saying is that if this side was some number, then this side will be the exact same number. So let's just kind of pick a random number. What if we said 3? Well, then that means that this side would be 3. X and x are the same thing. Now, over here, we have x square roots of 2. All that means is that you just have to do 3 square roots of 2. It's pretty simple like that. Now, this case right here is kind of the trickier version. So what we're saying is that that 18 is in the position of x square roots of 2. And so the question then becomes, how can you solve for x? How can we find these side lengths of DC and DB? Well, in order to get the x by itself, since x is being multiplied by the square root of 2, all we have to do is divide by the square root of 2. What we do to the right, we of course do to the left. Now, if you're operating without like a traditional calculator, what you need to do is go to your cell phone, go to the calculator, turn it on its side, and you're going to take the square root of 2. And what you'll notice is that the square root of 2 is actually going to be roughly, let's see, we'll have 18 divided by 1.41. If we round to the nearest 100th, 1.41. And I do apologize for these stylus issues that I'm having. It's making the writing just a little bit difficult. So we'll take 18 and we will divide that once again by 1.41. And that will give us a side length of 12.77 once we round. Once again, rounding to the nearest 100th. And this will be in inches. Now, what are we really saying here? We're saying that we use this special right triangle to find these sides right here. But what are those sides really? Well, they're these sides right here, BC and BD. I'm sorry, CD. So we could say, hey, this is 12.77, and this is also 12.77. And since we're finding the perimeter, all we have to do is add up the sides. Well, since all four sides of a square are the exact same, we can simply just do 4 times 12.77. And if you go into your calculator and you do that, so times 4, it will give you roughly 51.06. And of course, it's perimeter, it's a length, so it stays inches. It's not inches squared or inches cubed. Alright, and this will help you out with the very first problem in these next 5 problems. Alright, I would encourage you to pause this video, finish taking any notes that you need, and let's go ahead and move on to example number 2. Okay, so in our second example, given quadrilateral ABCD is a parallelogram, and EC and BE are angle bisectors, and angle ECD equals 58 degrees, we want to find the measure of angle BEC. Now you'll notice there is a lot of information there. So let's kind of start labeling some things. One, we know it's a parallelogram, so it never hurts to go ahead and use a couple of arrows to just say, hey, we know that these two lines are going to be parallel to each other. All right, what's the next thing we're given? We're given that EC and BE are angle bisectors. So if we look at this line, BE, we could draw one curve here, and we could draw one curve here. We also know that EC is an angle bisector, so to show that this angle is cut in half, we could actually use two arcs, and here we'll use two arcs as well. So we know that each one of these angles is in fact congruent to the angle that's adjacent to it. Now the last thing we're given is that angle ECD is 58 degrees. Let me just draw kind of an arrow in here. Let's see, ECD. We're saying, hey, this guy right here is going to be 58 degrees. Now let's kind of start working through this. Oh, and by the way, one final thing. We want to know this angle kind of right here. Okay, so let's do a couple of things here. One, since EC is an angle bisector, we also know that this angle right here will be 58 degrees as well. So if I were to ask you, what is this entire angle? Well, we know that it has two parts that are both 58 degrees. So we can simply say, okay, what is 58 plus 58? And let's see, if you were to use your calculator, you would find that 58 plus 58 will in fact give us 116 degrees. Okay, now the next thing we know is we know that quadrilateral ABCD is a parallelogram. And how is that helpful? Well, it tells us that any angle that we know, we also know its consecutive angle. So if this angle right here is this 116 degrees, then in order to find angle, let me just write it like this, angle ABC, all we're going to have to do is do 180 minus that angle BCD, which was 116, and you know, in anything like this, I just encourage you to use your calculator. So pulling up my calculator as well, we'll say, okay, 180 minus 116 will give us 64 degrees. Okay, so now that we know that this entire angle right here is 64 degrees, and we know that EB is an angle bisector, what we're really saying is that in order to find this angle, this small one right here for EBC, all we have to do is do 64 divided by 2. So we can cut this number in half and ask yourself, what is half of 64? Well, that will of course give us 32 degrees. Okay, the last thing that we want to kind of look at here, and I know that I've put a lot of work down, so let me actually grab an eraser. I really want to, well, that's erasing too much. So we have this triangle right here. I'm just going to really embold it since that eraser is taking on too much away. And for that triangle, we know both of the base angles. So if I were to draw that triangle right here, we're looking for this top angle, which is on our original triangle, angle BEC, and we know that this angle right here was 32 degrees. And we also know that this angle right here was this original 58. So all we have to ask ourselves is, what do three angles of a triangle add up to? Well, we know that three angles of a triangle add up to 180. So all we have to do is 180 minus whatever 32 plus 58 winds up being. So let's just add those, 32 plus 58, and that will give us 90. So it turns out, in fact, the angle that we were searching for was 90 degrees all along, and in fact, was a right angle. So the answer is going to be angle BEC is equal to 90 degrees. All right, pause the video, take any notes that you need. Let's move on to our third example. Okay, here we have example 3, and we're given quadrilateral ABCD is an isosceles trapezoid. Now I wanted to deal with this one specifically because we didn't touch upon it in our level 3 video, but all it is, it's a trapezoid where these base angles ACD and BDC are congruent, and I even gave you that right there. Now once we know that, that actually makes this problem a whole lot simpler. We also know that AB is parallel to CD, which implies we could consider these consecutive base angles. These are consecutive base angles. And then when you look at this angle at A and this angle at C, these would be our non-consecutive base angles. Okay, it says find the measure of angle CAB. So let's see, so here's CAB. So we want to know what is that right there when ACD is 3x minus 4. So ACD, so that will be 3x minus 4. All right. And angle BDC, so BDC, it's this other base angle, is going to be 2x plus 2. With angles and quadrilaterals, you're essentially always asking yourself this question. Are the angles congruent or are they supplementary? Well, in this case, since they're both congruent base angles, well, of course they're going to be congruent. So, when two angles are congruent, we know that we'll take this 3x minus 4, and of course we are going to set that equivalent to the other angle, which is 2x plus 2. Now remember, when we have x's on both sides of the equation, we always want to move the smaller one. So we can go ahead and subtract this 2x. And when we subtract 2x from both sides, we really wind up with 3x minus 2x. And of course, what is 3 minus 2? Well, you know that. That will be 1x. And in this case, minus 4. And that will be, of course, equal to positive 2. Now, how can we get rid of that minus 4? Well, we can do plus 4 to both sides, and plus 4 again over here. And you know that 2 plus 4 will, of course, give us x equals 6. Now, just because we found x doesn't mean that we've actually answered the question. The question becomes, find the measure of angle CAB. CAB. And we actually don't even have a formula for that. So we're going to have to find this angle that's right next to it, this 3x minus 4. And notice I replace my x with a set of parentheses. We do that anytime we're going to plug anything in. And within that parentheses, we can go ahead and put our 6. 3 times 6 will, of course, give us 18 minus 4. And 18 minus 4, we know that that is going to be 14. So if the question was asking, well, what is the degree measure of angle ACD? ACD, we know that the answer would, of course, be 14. However, once again, we're not looking for that. We're looking for the angle that is the non-consecutive base angle. So we're looking, the consecutive non-base angle. This angle right up here, CAB, and we know that whenever these two angles are beside each other, that they're going to add up to 180 degrees. So all we have to do to finish this problem off is simply do 180 minus 14. And that's probably one you could even do in your head. We know that 180 minus 10 would be 170, and minus that other 4 will drop us all the way down to 166 degrees. So our answer is going to be 166 degrees, which is how big this angle CAB is. Alright, that's it for our level 4 video. I hope that these have helped you out, and I'll see you on our next topic.